Hi everyone, today we'll be looking at Advent of Code 2023 Day 6, going into the problem blind so you can see how I approach the problem and code up my solution. Yeah, I haven't seen anything about this problem, though I did check the leaderboard. It looks like it's getting completed faster than the last one, so hopefully we have a bit of an easier time. But yeah, let's just get into it. 6. Wait for it. The ferry quickly brings you across Island. After asking around, you discover that there is indeed normally a large pile of sand somewhere near here, but you don't see anything besides lots of water and the small island where the ferry is docked. As you try and figure out what to do next, you notice a poster on a wall near the ferry dock. Boat races, open to the public. Grand prize is an all-expenses trip to Desert Island. That must be where the sand comes from. Best of all, the boat races are starting in just a few minutes. You manage to sign up as a competitor in the boat races just in time. The organizer explains that it's not really a traditional race. Instead, you will get a fixed amount of time during which your boat has to travel as far as it can, and you win if your boat goes the farthest. As part of signing up, you get a sheet of paper, your puzzle input, that lists the time allowed for each race and also the best distance ever recorded in that race. To guarantee you win the grand prize, you need to make sure you go farther in each race than the current record holder. The organizer brings you over to the area where the boat races are held. The boats are much smaller than you expected. They're actually toy boats, each with a big button on top. Holding down the button charges the boat, and releasing the button allows the boat to move. Boats move faster if their button was held longer, but time spent holding the button counts against the total race time, and you can only hold the button at the start of the race. But boats don't move until the button is released. Really small. Okay. Yeah. So 3 races. Looks like the units are millimeters and milliseconds. So you start holding the button at the start of the race. Okay, for each millisecond you spend holding down the button, the boat speed increases by 1 millimeter per millisecond. So we're sort of trying to optimize, given the time, how long to hold down the button. Got it, got it. Okay. Interesting. So we got some math here. I'm sorry, I wasn't talking, just reading this. So looks like you can hold down the button for an integer number of milliseconds, and then yeah, you need to beat the record, not tie it. So in this example, well, I guess we couldn't tie. I think, yeah, we need to beat the record. Yeah. Okay. Um. Yeah. Let's get into it. And let's grab the full input too. Okay. Yep, using the same template as I have been. Let's just set up um, let's set up our little script that'll watch for when we save the file. So first, let's parse the input. That should be, I think, quite straightforward. So we have 2 lines times, let's just use regex. Simple find all on the numbers. And then for distances, we just want to look at the next line. Let's print that out. And that is correct. Let's just cast those to integers. All right, cool. So we have our times and distances. Now we're just going to iterate over these 2 lists. Now we have to think about how we actually compute. Here we'll store a list of the number of solutions for each pair. And then, so we'll in here we'll like append the num solutions, some value that we actually need to compute, obviously, and then at the end we just want to compute the product of that. Yeah. Okay, so now we need to do the actual main part of the problem, which is computing the number of ways to solve. Yeah. So I think that at least in this example input, we could just manually compute everything. So, or even in the full input actually, where we, they're only like, since we can only hold the button for an integer amount, we can just manually compute like the distance we go, given we hold a certain amount. I think that that should work. To potential improvements, we could, so you can think of this function. So we have a function like get distance, which takes, here, let's just code this up explicitly. Which has a button time and then a total time, and then returns a distance. Whoops. So let's see how this is going to work. So speed, this is quite simple. So we have our speed is equal to the amount of time we hold the button. So we have speed, and then the amount of time remaining is the total time minus the button time. So yeah, I think that we could take sort of like a mathematical approach. This is just, we have a simple like quadratic function. And so we can find where this intersects with, where this parabola intersects with like the distance. However, let's just keep it simple for this part 1, and then we can make any optimizations if need be for part 2. So we can hold the button for from 0 seconds, which obviously we never do in practice, all the way to um, the full time, and then if get dist button time total time is greater than the record distance, then here we should just have a counter. Let's just call this just solutions. We can just increment the count. And then just do something like this. So we have 288, which is correct. Obviously, this can easily be optimized, or not super easily, but using like the math we talked about. But let's just leave it for now because it works, and run it on the full input. That still obviously runs really quick. All right, that's right. Close. Now to part 2. Ignore the spaces between the numbers on each line. Okay, cool. So yeah, now basically we have to concatenate these numbers, and so we're left with a much bigger time distance. And oh, excuse me, that means our previous solution, well, honestly, I think it probably still would work, but let's just copy this to part 2. So now we're going to get only a single time. So okay, instead of, we want to join this and cast that to an integer, and that's just a single time. So let's make sure these are working. Whoops. So yeah, that's correct. Now let's just try the other solution. I mean, time is still not that big, so we're only going through 70,000 of these options. So really, I think this will still work fine. We might want to, just for kicks, implement a better solution afterwards, but I think this should actually work totally fine. That doesn't, does that seem right? That's not right. Your answer is too low. Interesting. What am I doing wrong here? Hmm. So this is obviously the exact same code. So it's a little confusing why. Oh, it's because I'm not running it on the input. Silly, silly, silly. Okay, yeah, well, we did get a solution. We're going through this many, which is whatever, 45 million times, which is, I guess, not that many, but yeah, that's okay. That is the right answer. I think this solution is not particularly satisfying to me, even though obviously it's totally effective. Because if this was a few orders of magnitude higher, then it would this wouldn't work at all. So let's do a solution that runs instantly instead of taking whatever 3 or 4 seconds to run. And to do that, we can just use a little math. So let's do a little graphing. So this is, we have our get distance function. Let's maybe do this on one of the initial examples. So what was it? Time is 7, distance is 9. So we have I don't know all how this works. So we have button time times total time minus button time. So button time will be on the x-axis, and then distance will be on the y-axis. So we have minus x squared plus x ax, where a is the total time. Yeah, so if the total time is 7, and then the distance we want to beat is 9, we can see that there are 4 integer solutions here, 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 and here. So basically what we want to do is find these 2 intersection points and then go like the next integer in. So here like we intersect at 1.6 and 5.3, and so know that take the floor of this and the ceiling of this to get 2 to 5 as our valid range. So yeah, this is, I mean, obviously a very simple math problem. We can just sort of solve here. Let's write this out. So we have that dist equals negative bt will be button time squared plus time times it's just button time times time minus button time. This is the formula's right here. And so we want to solve this for button time when we know dist and time. So yeah, that sorry, I'm like glitching. This is pretty straightforward. I don't think there's like an easy way to factor this out, but we can just use the yeah, it's just like a little weird writing this out versus on paper. So maybe I'm just gonna write this out and then come back in just a sec. Yeah, so I don't know why I was just blanking hard there. Took like a minute, but obviously we're just using the quadratic formula here. It's finding the roots of this function. Um, so we have sort of this fraction. Um, that's like plus or minus, and then square root of d squared minus 4a um, all over yeah. So okay, yeah. So we have this is just -1. I don't know why I did minus pt. Okay, so simplifying this out a little bit, we have that the button time is equal to the time plus or minus square root of time squared minus 4 dist over 2. Okay, yeah, so we can calculate this super easily. So here we're going to have a low and a high value for this based on whether we add or subtract this uh, this second statement here. So the low is going to be time plus just import the square root of time squared minus 4 times dist all over 2. And then, so the low value will subtract here, and then the high value will add. So let's just run this on our example where we had time is equal to, what was it? Time is equal to 7. This is equal to 9. And then we can print and then 1.69 and 5.3. So that looks like it is indeed correct. Let's just get the floor and the ceiling. So the number of solutions is equal to the ceiling of the low. So the range is from the floor, the high. So that'll be like our range, and then add 1 to count for both endpoints. And then I think we can just return this count. Yeah. So that is indeed the same solution. All right, I think that'll do it for today. This problem was pretty straightforward, but even though there was some mental slowness on the second part, I'm glad we ended up calculating this cleaner solution. Yeah, because it's nice to know that although we could brute force it, it's quite simple using a little math to compute the count explicitly. All right, that'll do it. Thanks everyone. Again, if you have comments, questions, comment them below. And I definitely, yeah, like hearing about things I can do better in these videos or just with my code. All right, thanks for watching.